In this example, we have the function f of x, which is x cubed plus 2x plus 1, and we're asked to evaluate its inverse at 3 different values in a, b, and c. And so we're told that f is a one-to-one function, and so that's good. So we know that we can think about its inverse. And rather than find a general formula for the inverse that undoes f, that's quite hard to do in this scenario since we only need to evaluate this inverse at 3 different values. Let's observe the following relation between f and its inverse that we can use to answer parts A, B, and C. So in each of these parts, we are trying to evaluate the inverse of f at some value we'll call b. And the property that we need to use is really the definition of what it means to be an inverse. And that is if I take f and compose it with its inverse, they undo each other. So if I plug b in, what I get back after composing these two is b. So what we can see here is that f inverse of b is the value when input into f gives me b. So, in other words, what we can do is set f of x equal to b and solve for x. Okay, so to figure out what I get out of the inverse of f at b is the same thing as saying what value do I plug into f and get b. Great, so in part A, the question is, what is the inverse of f when I evaluate it at 1? And using the observation above, what we see is that this is the same thing as setting f of x equal to 1 and solving for x. So that gives us f of x is equal to x cubed plus 2x plus 1. We set that equal to 1 and solve for x. So solving for x, we can subtract 1 from both sides, and that would give us an equation x cubed plus 2x is equal to 0. And so solving that equation, we can factor the polynomial on the left side into x times x squared plus 2 equals 0. So for each of these factors, we can try and identify zeros. And from the first factor, we get a very clear 0 at x equals 0. And from the second factor, x squared plus 2, there's no value of x that makes that factor 0. And that's a good thing because we're told that this function is one-to-one. So there should only be one value of x, namely x equals 0. When I plug into f of x, that gives me 1. So since f of 0 is equal to 1, we know f inverse of 1 is therefore equal to 0. So f inverse of 1, again, is the value that when I plug into f gives me an output of 1. So we're going to use this same property to answer parts B and C. In part B, we want to evaluate the inverse of f at 13. And so just like in part A, what we're going to do is we're going to set f of x equal to 13 and solve for x. So in this case, that means the equation is f of x is equal to x cubed plus 2x plus 1, and we set that equal to 13, and we want to solve this equation for x. Okay, so what we could do is try and go through a similar process as we did with part A, in that, okay, I want to solve this, so I'm going to subtract 13 from both sides, and that gives me this equation, which I can then try and factor the left side. But this side is not that easy to factor. We certainly could do it. So rather than solve this algebraically, let's instead take a graphic approach. So we can take the function f of x up here and plot the graph, say using a calculator or Desmos or some other form of technology. And that graph I've plotted over here on the right. And so what we're looking at again is the graph of this function f of x, not the inverse, but f. And what I want to do is solve the equation when is f of x equal to 13. So here is the value 13. So for what value of x do I input into f that gives me an output of 13? And I can see over here that we've got a point at 213. So this means when x is equal to 2, f of x is 13. So f of 2 equals 13. Well, that's enough to tell us, therefore, that the inverse of f at 13 is therefore equal to 2. So that solves part B for us. And again, rather than do that one algebraically, if we can see the graph, then we can answer these questions visually. So that's the way we'll take a look at part C as well. So in part C, we want to figure out, well, what is the inverse, what is the value of the f inverse at minus 2? And so to figure out what this is, we need to solve what value of x when I plug into f gives me minus 2. So I come over to the graph and I notice that here we have a point at minus 1, minus 2. The value minus 1 is hard to read, but that's over here. So each of these tick marks is 1 unit. So at this point, we're at an x value of minus 1. And since f of minus 1 equals minus 2, we see, therefore, f inverse of minus 2 is equal to minus 1. So that answers part C.